Hello everyone, welcome back. So in the previous video we have done electromagnetic phenomena, of course iGCSE physics and O-levels physics. We have done one question in the previous video and we'll continue the concept by doing some other questions. So the next question says that figure 10.1 shows a variable resistor and a solenoid connected to a battery. So this is a battery and that is connected to a variable resistor, and the variable resistor is something that the resistance of which we can vary, and then this whole thing is connected to a negative terminal of battery going to the solenoid. Okay, so the question says that if the current flows through the solenoid, it will behave like a magnet. Obviously, it will produce a magnetic field. This is very obvious thing, that whenever there is current in a solenoid, it behaves like a magnet. And now the question asks you to draw the magnetic field of this solenoid. So magnetic field, we can draw the magnetic field patterns. We know it behaves like a bar magnet, so it will have a similar magnetic field pattern. But the thing is that we need to know the polarity of the solenoid. That means which pole is north pole and which pole is south pole. So for this, the very important concept to be considered is how to get the polarity of a solenoid. Polarity of a solenoid basically means to know which pole of the solenoid is north pole and which pole of the solenoid is south pole. So to get the south and north poles, we have a very important rule, which is grip rule, or a right hand grip rule, we can say it, because it's applied on the right hand of a person. So grip rule, and we can more precisely say it's a right hand grip rule. So according to this rule, you have to curl your fingers in the direction of current, like wherever the current is flowing, you have to move the fingers of your hand along with the direction of current. So in this case, the direction of current is this. So we are curling our fingers the way the current is moving, and then our thumb will predict the north pole of the solenoid, and the other end would be south pole. So this is the way we find the polarity of a solenoid. Let us just apply the same rule in our solenoid. So we have a battery this side, the positive terminal is upside, so current will flow this way. Yes, and let me make the arrows in the coil over here. So it will enter from this side and goes all the way to the coil and exit this side. So this is the pattern of current within the coils, and we can continue this pattern all the way to the solenoid. Okay, so if we clearly see this pattern and we just we just curl the finger of our right hand in the direction of current, wherever our thumb will point will be our north pole. Okay, so in this way solenoid, we can see clearly that our fingers should curl inward as the current is flowing inward. If we notice the first coil of the solenoid, the current is flowing inward. So let me just make a pattern of fingers, and the thumb of finger will point downward because it's a right hand. So if we curl our finger inward, the thumb will obviously go downward. So this a downside pole is north pole and the upside pole is south pole. So after getting the poles of the solenoid, we just write it this side to make some space to draw magnetic field of lines. So let me change the color. Yes, so magnetic field of line will follow this pattern. They will exit from north pole and they will enter the south pole. So emitting from the north pole and entering the south pole. I am drawing two patterns on each side of the line, and you can clearly see that the arrows are pointing upward. Okay, there are a few very important facts that need to be considered when we draw the magnetic field patterns of a solenoid. That is that the magnetic field of lines or magnetic field is uniform inside the solenoid. Now what does this mean? Uniform inside solenoid basically means that the magnetic field of lines should be same distance apart. So this should be same distance apart. The second fact is that magnetic field is always stronger near the poles of a solenoid. So when you are drawing the magnetic field patterns, they should be closer near the poles, and when you move apart, when you move away, they should move apart as well. So stronger near the solenoid. And third thing, let me write this thing as well, that they should be closer near the poles. And when you move apart, the magnetic field is weaker, so weaker away from solenoid. And when you discuss about the magnetic field of lines, they should be far apart from each other, away from the solenoid. Okay, now the fourth fact, which is very common and very famous, that magnetic field of lines never cross each other. So if you're discussing the magnetic field property, this is very important, that your lines never overlap each other, and whenever you draw these lines in your paper, don't ever intersect each one line to other line. Okay, so field lines never cross each other. Okay, so the question says, state the feature of the patterns of magnetic field line that indicates the strength of the magnetic field at the particular point. So we have already discussed this point in our facts, that if the magnetic field of lines are closer, magnetic field is stronger. If they are apart, magnetic field is weak. So the density of lines basically decide the strength of the magnetic field. So density of lines is the answer. The greater the density, the closer the lines. The lines should be closer when the density is more, and the closer the lines, the greater the density, the closer the lines, and the greater the magnetic field. Or you can say magnetic strength, or whatever you want to write, it's totally upon you. So density of lines is the thing that decide about the strength of a magnetic field. Okay, the part B is saying that state and explain the effect of magnetic field of the if the resistance is increased. So basically what happens when you increase the resistance? This is a variable resistance, so the resistance can change. So if you increase the resistance of this resistor, what happens? Okay, when you increase the resistance, it will block more current and it will let less current to pass. So increasing the resistance will affect the flow of the current, so it will reduce the current flow. And if the current is reduced, this is very obvious that the magnetic field strength would also be weakened. So the answer is that increasing resistance will reduce the flow of the current. That means it will let less current to pass through. So less current will produce weaker magnetic field. Yes. So this is the answer. Now moving to the third part, the C part of this question. Now this part is very important application of Fleming's left hand rule, so you just listen it carefully. In a laboratory vacuum chamber, some current carrying coils produce a strong magnetic field. So this is circle is representing small magnetic field, and there is some source of alpha particles near this magnetic field, and we have to predict the deflected pattern of this alpha particles. So why do they get deflected? What is the fact that why they get deflected is that alpha particles are charged particles, so positively charged particles, and we know that if they are moving, so that if they are charged particles, they are moving, so this movement is current, because movement of charges is referred as current. So this is the movement of current, and there is a very strong magnetic field which is acting into the page, that means towards the screen of your computer or mobile. So when the current is flowing inside a magnetic field, it will experience a force of deflection. So current will experience, or current, or we can say charged particles will experience a force due to this magnetic field. So this was the actual pattern of the alpha particles, but due to this force they'll get deflected, and we have to get the direction of this by this Fleming right hand rule, the direction of the force, which is upward. So the alpha particles will deflect this way, making a curve from their actual path. So this is the deflected pattern of alpha particles. And why do they deflect? They deflect due to the force which was acting upward. Now how do we come to know that this force was acting upward? This is a very important thing to be considered. Now we use Fleming right hand rule. We move our forefinger into the screen, middle finger in the towards the right hand side, and we see our thumb will act upward, so they will experience an upward force. Now state and explain the effect on this path of reversing the current in the coils. Of why, if you reverse the current in the coil, what happens? If you reverse in the if you reverse the current in the coils, the pattern of magnetic field will reverse. So this will also reverse the force. So if the force was acting upward before, now the force will act downward. So these were the coils which were creating the magnetic field. The first line of the question explained us that the magnetic field is produced due to the coils. So now if we reverse the direction of current in the coil, this will reverse the direction of this magnetic field. So now this magnetic field will act towards your face, not towards the screen. So if we reverse the direction of current, direction of force will be reversed. So now it will act downward.